very straightforward lab. We pour the blue stuff in a dish. Okay, turns blue. Then we heat it, and it should. We weigh it out first. Then we heat it. It starts as this kind of. When it has water in it, it's blue. And then after we've heated all the water off, it is then like this nice. This is terrible view of it. It just turns into like this pale, dull gray powder. Okay, so it turns into this off-white powder, and that's what signals to us that all the water has been boiled off. Okay, so looking through this hydrate, the numbers on the simulation doesn't make much sense. So what I will do is give you your experimental numbers. Okay. And I've made up some experimental numbers for y'all. And these are your own individual numbers. I put them up on the board. This is the best way I can share it. So we're all pretending that we did this lab. And we all nailed it and we got exactly 2 grams. Okay, nice work. You all did the lab. Nice work. Even Leo did it. And you got a variety of results. I used a random number generator, so we'll see what happens. Okay. So the goal for today, after I'm done talking, is to try to figure out what your empirical formula is. So the real number that we're looking for is going to be copper sulfate 1 to X hot H2O. The goal is to get to 5, or that's our theoretical. And then your experimental value will be based off this number. So you can go ahead and copy down the number that's by your name. So your starting number is 2, and then your experimental number will be the individual one here. So if you can't read your number, you can let me know. Oh, you are the last one, yeah. Oh, yeah, and this thing is in the way. Yeah. So what we're doing is doing like a mock lab to be able to talk about percent error. So I've given you some numbers to work with. Your starting weight is 2 grams, and then your final weight is 1.21. Okay.
We're supposed to have 6. That's good. On the back of this.
Yeah. We'll just start with 1, and for additional data, we can pull from here.
He's trying another sentence.
Okay. We're still. I'll just give a few more seconds to copy down your numbers, and then I can always go back and let you know what it is. So 2.93. Okay, 2 grams. Three, and then water went to. Where's freaking 9? Okay. So we all weighed out 2 grams. We heated it, and then we should have our data. So I will use Leo's data to help us with this today. So Leo started with 2.0 grams at the beginning, which is copper sulfate and our water. Okay, you'll see, yep, all together, and it's blue. So you can see my particle diagram here. So I was following the kind of rules I set up yesterday. Copper is the dotted one. There's 1 copper. There's 1 sulfur. There are 4 oxygens that are attached to the copper and sulfur. And then what do you see that are attached to the outside of this? And I'm missing, I think I'm missing a water. So yeah, I've got like, so this is probably what I did for my general chemistry class. I didn't, because the goal of the lab is to figure out the number, I was intentionally trying to throw them off. Okay, so if this were real, I would need another, I'd need another water. Yeah. Now I see. Aha. Like right here. Okay. Got it. Great. Thank you.
It just doesn't really make sense.
Yes.
Why are there 2 just
Correct. Okay. So now I should have it good. Okay. So we start with this, and then we heat it up. Water has a low evaporation point, much lower than copper sulfate. So the copper, sulfate, and the oxygen stay, the water will go. Okay. So if we have now we heat it. So heat, and then let's find this. Just a minute here. Why is this taking so long? Okay, so now we have this. We heated it. We should have no water left. Okay, and I have 2 copper sulfates here. Let's just like. All right. So we have 2 grams. 2 grams CuSo4. Now I'm going to use Leo's numbers. He has 1.293 grams. So this is XH2O. And so this is 1.293 grams of what? What does the picture tell you? Is there only CuSo4 left over? Correct. CuSo4. All right. And then what I also like to do is kind of like the water was there. It has to be kind of like there to keep track of. So yes, it got lighter, but did the water disappear? Did we make it not exist anymore? It just evaporated. Okay, so it went out into the air, so our mass is conserved in the universe. So we have X grams of H2O into the air. Okay, how can I find the amount of water that was lost? Subtract what?
Final mass.
final mass from the 2 grams. So like it kind of works like this in math where you're like 2 CuSo4xH2O, 2 grams minus 1.293 grams of CuSo4. Okay, the labels work the same way in just with addition and subtraction. So I take that, I subtract them, and I should get 0.707, I believe. And then that's grams. So if you take copper sulfate and you subtract copper sulfate, we should have XH2O left over. Okay? So these are the like procedures we need to follow in chemistry to like always make sure we're keeping track of the stuff we started with. Okay? So you can have good lab technique, but if you're not like lining up your numbers and you don't know where your numbers are coming from, you'll never be able to figure out labs. Okay? So just trying to build some of these habits early on. So we've got grams of H2O, we've got grams CuSo4. Is this enough data to understand how many moles of this and moles of that we have? Is it enough data? Yeah, because we can always get grams into moles. So we have, we now have 1.293 grams. Let me. I'll go to a new window. I'm running out of room here. So 1.293 grams CuSo4. Okay. And then we have 0.707 gram H2O. And that's grams mole for mole. And everybody show me on one hand what should be on the top. Uno, okay? Moles to grams, we always use 1 if we're using the periodic table, okay? So put a 1 up there. The molar mass of copper sulfate, that's something you guys can do on your own time. I usually just Google it, but you can't Google it on the test, so you need to know how to do it. So take copper 63 plus sulfur, which is 32. That's approximately 90 something, and then we add 4 oxygens, which is 16 each. Add it all up, and 159.07. I have 159.6.
Yeah, 0.607.
607. Ah, nice. Okay, so 159.607. Great. Turn that into moles, and then 1 goes on top of here. Hydrogen, you don't have to memorize molar masses, but if you use them enough, then you hopefully remember. Hydrogen is 1.0078. Oxygen is 15.998. Add those together, 18.01 grams. If it seems like I'm rushing through this, it's because I want to talk about the error analysis at the end of this lab. And I can certainly slow down and fill in any gaps. Okay, so I'm going to color code this. So this is mole Cu. No, I want it blue because copper is blue. Okay, mole CuSo4. And then water, I guess, is kind of blue. Let's make it like, I don't know, red. Mole H2O. Okay. Convert it into moles. We should all, oh no, ours are all going to be uniquely different. So I would like you to do your own numbers. Okay. So I'll do Leo's. So moles of CuSo4, 0.008102. Okay, that's 0.008102. when you're using empirical formulas, give yourself some leeway after the first significant figure. Don't just write 0.008 because it might give you some goofy rounding. So give yourself a couple extra. So that's 0.008 moles, and this is, God, where did it go? Jeez. 0.039255. So I'll say 3926. Okay, 0.03296. So we have both of these that we want to, so we have grams into moles. We need to divide by the smallest and multiply until whole. Okay, which one of these is your smaller number, the copper one or the water? Copper, right? Because we know it's going to be 1 to 5, so copper should be smaller. So let's divide both by 0.08. Oh, I did the. No, okay, nice.
What would you divide it with?
No,
Okay, let's do this. This divided by this.
what?
So what does that mean? Equals this. So I would divide it by
Is that close enough to one?
Okay. Yeah, it's much better. All right. So divide by the smallest. Divide this by 0.008102. So this is going to be 1 CuSo4 for every. Divide this by 0.008102. And let's 0.485. Run out of room. 0.485. Okay. Oh, not 0. 1.485. No. 4. Why? It's Friday. Okay. Yeah.
I got 4.6. Is that still close enough to round up to 5?
So this is where us as scientists, we must use what we know to like best use our data in the right way. So do we know it needs to be a whole number? And so what whole number does that round to? It should be 5. Okay. So like this is one of the times where the percent error is a little wonky because you're comparing two numbers versus like, so we kind of just do the best we can. So if this were like, if I didn't even know what this was, that might throw us off. Like, because to get a whole number, we might have to do like 100 for every 485 molecules, which is a little weird and wonky, but it's kind of the best we can do. So this is also to show that like experimental error is what it is. And we need to use that information to help us determine why we got either high or low. Okay. So really, all we do is if I'm going to copy this, and then I'm going to copy that. So if I go here, and then paste, where did it go? Come on, man. All right. grams into moles Cu grams Cu over moles H2O. Okay, this is H2O. So really, all the calculations of this lab boiled down, pun intended, to only two numbers: moles of Cu versus moles of H2O. Okay, so percent error analysis is basically the same as percent yield, but like we're looking into why it is the case. Okay, so who got a number that was lower than 5 for the final result, 1 to like 4.6 or something? Who got a number lower than 1.5? I'm sorry, than 5. Okay, who got a number higher than 5? Okay, so now we are scientists. You should have gotten something close to 5. What did you get?
My number came up with 3.3.
That okay? That's not terrible. I mean, it's not 1 and it's not 10. So you probably is your number. What is your number? I guess that's the final result from 2 and the other one. Your experimental number.
The change in mass is like 5.5434 grams. And when I took it the number, the mass, it became 3.304.
So the amount of grams of water is based off the second number, right?
Yeah.
And then the amount of grams of copper is based off of the first number. Okay? So if the ideal number is 5, the moles of Cu divided by the moles of H2O should be 5. If your number, so this is the crucial part. I need everybody to, if I lose you now, the rest is going to be difficult. Okay? So this is nominal. Nominal means like what we want. Okay? If we are lower than that, then that means what number must be large? Like the moles of H2O, must this be larger or smaller to make this lower? So when you divide by a larger number, you get a smaller number. Okay? So if this is lower, then mole H2O is too much. Or higher. Okay? Are you with me? So now, if in different color, let's do up here, if it's higher than 5, what must this number be? Smaller than expected. Okay? So mole H2O smaller than expected. Okay? So on your labs and any sort of AP thing we do, you will get a question like this that will ask you your error analysis. Okay? The goal is not to get perfect because we know what it is already. The goal is to see how close we can get and then look at our results and be like, oh, I didn't boil off enough water. I need to heat it more. Or I have too much water. Or my mass is like.
Is that like if you burn some of the Cu off or something?
Yeah.
You burn it off. smoke.
Yeah, so if you were to smoke it and like actually push off some sulfates or probably some oxygen that's coming off of there, that makes your final mass lower. No. Hot. If you, yeah, so this is where it gets tricky. So your final mass is based on H2O, the amount of H2O that's left. Okay, so let's go through some strategies. If you don't boil off all the water, so H2O not, or just not heated enough, so there's more water in there than we need. So that will make this grams higher or lower. If it doesn't boil off, higher or lower? Yeah, if we don't heat it off, it's still there. The amount of this is based off the water removed. So it's subtracted. So if there's still water left over, this will be smaller. Right? Because actually, and this is why I have the pictures in front of us. Let's say we have a couple more waters. Right? If a couple more waters are left over, that weight will increase, which means not everything will be boiled off. So the total grams that we subtract will be smaller. So then if we carry that through, if we have fewer grams, that will convert to fewer moles. So that makes this smaller. So then if we divide by a smaller number, that makes this number lower. So if you got a number less than 5, what can you probably guess with your data? Too much water left in it, and maybe we need to heat it more. Okay, so now work backwards. Another thing like,
How do we know it's 5?
yes, but you only find the water by subtracting it from the original amount. So if that water doesn't boil off, so we start at 2 grams, the weight starts to lower as we're heating it. And I want to get down to here. If I get all the way down to here, that means I got all the water off. And I have a larger difference from where I started and where I ended. Larger difference means bigger grams.
Okay.
So bigger grams carries through to bigger moles, and divide by bigger number, lower the amount.
Okay. So then, if I had way below it,
So
then you have.
yeah,
So it's like opposite. So it's like what you would think
exactly.
is
Exactly. And what I'm saying is that instead of trying to memorize what happens in every single lab, you can work backwards to find that opposite relationship. Because so many students are like, oh, more water, it's going to be bigger. Bigger how? What are you talking about, right? You need to be specific. So, like Caleb was saying, if I burn the crap out of it and I start literally smoking out that copper sulfate is going out in the air, so heating too much. So heating too much, I lose a lot. So if I lose a lot, I'm subtracting a lower number from my beginning. So this grams, if I'm subtracting a smaller number, I should have a larger number of grams. So that'll be bigger. So that'll make more moles of water. And that will make, if I divide by a larger number, then I get divide by a larger number, we should get a bigger number, and then I'm up here. Okay. So those of you who have a higher number, you can say, I burnt it too much, or I spilled something somewhere along the way, and my weight is artificially lower than it should be expected. Okay, yeah.
So if this is a question that is asked on the AP exam, will they tell us what the perfect number would be?
Yeah, yes.
Okay.
So there are 2 questions on your take-home quiz that are the long free response questions. They're pretty much all based on labs. and they kind of detail it to you. And it'll be just like this. You came in the lab, your first weight was 2 grams, your second weight was this. If you didn't heat it enough, what would you expect to happen to the final number? Okay, and your answer will be, it will be higher than 5 or be lower than 5 because that. The bad answer is, it's gonna change, right? Like, that's not specific. Yes?
Is it gonna be like paper type?
Yeah, I've got it here, and that's basically what I wanted to talk over with percent error. So I have the take-home quizzes that you guys win. 30, okay, 30, yeah. I will give that to you right now. And so these are the take-home quizzes. I understand when I give you a take-home quiz, I cannot police what resources you use or what you do outside of this class. If you Google all the answers, it doesn't help you. And I have ways for you to improve your grade and your learning. So please just do the best you can. Since this is the first quiz, I haven't seen how we've actually really done. If you look at it and it's on Sunday and you're like, oh dear, what is Mr. Mark asking of me? This is crazy. I can't believe this. My goal is not to ruin your weekend. If you can't figure it out, then come in and ask questions. I want your best work, is what I'm saying. Because this is a Friday and it's your first weekend, if you want more time, I will take it by Tuesday.
The grade can ID, the student ID.
Yes, just your student ID, the six number, whatever. And I'm gonna stop the video.
You know what's really fun?